Well, the guys have gone. Nobody is here.
Yeah. Close to the exams, I guess everyone's studying, maybe.
Yeah. Yeah. Can you try question 1, please? And you
Yeah.
have time. Yeah. Oh. Hi guys. Thanks for coming.
Thank you.
Alright, try question 1, guys. I'll give you a few minutes to do question 1. So this exercise sheet is on one sample test of hypothesis, which we talked about last week, right? So you should go to let me show you. Oh yeah, here we are. So this is this is one of the tests that you need to use. You can see it here, guys. This is you need to, because there are, or basically there are 4 different tests, right? Tests for population mean when the population variance is known, when the population variance is unknown, and tests for population standard deviation, and tests for population proportion. So for the first question, for question number 1, you need to use one of these tests, because question 1 assumes that the population standard deviation is known, right? All right. Anyway, can you? I'll give you a few minutes and see if you can do question 1. Yeah, you okay? Mm-hmm. Yeah, you could. Yeah, you are right. Yeah, it should be. This should be. There's a mistake in this solution. I think there is a mistake here. It should be. So can I write here or something? What? It should be like this. It should be like. It should be like. It should be like minus z 1 minus 1.2 here and plus z 1 minus. It should be like this. It should be like this. Okay. symmetry here, you can replace this by, because of symmetry, this is equal to 0 divided by 2 here. This is equal to 0. They're the same. They're the same. Yeah. Okay. Alright. Can you do this question 1, please? First of all, I gave you already 5 minutes, so if you haven't done it, let me show you how to do it. Okay. Right. Alright, let me show you. So basically you will need to use, okay, let me switch this back to the document. Alright, let me switch it back to the document. Okay. So what you have in question 1, part 1, alright, what you have is you're trying to test for the hypothesis that mu is the mean breaking strength equal to 200 versus the alternative that mu is not equal to 200. Right? Alright? And let's write down what was given to us. We are told that the n, the sample size, is 40. We are told that sigma, which is the population standard deviation, is equal to 30. Right? And we are told that x bar is the sample mean, right? This is the sample mean, so it's gonna be 8328.4 divided by 40, which is gonna be equal to 208.21. So this is all the info that's given to us in the question, right? Now we need to determine what rule to use, guys. So can you tell me, guys, what's the rejection rule in this case? Because the population variance is known, or the population standard deviation is known, the rejection rule is what?
The absolute value of
Yeah.
the
Yeah, exactly.
mean minus me 0 over sigma over square root of n.
Square root of n, absolute value greater than z1 minus alpha by 2. Right, so this is the rejection rule. I showed you this a minute ago on my website, right? So what you need to do now is to work out the left and the right hand side. So let's start with the left hand side, which is x bar, we just found out, is 208.21 minus 200, sigma is 30, n is 40. Right, if you work this out, this will be 1.731. Okay, that's what you get for the left hand side. For the right hand side, depends on alpha, right? So the right hand side, if you take alpha to be 0.05, then this is 1.96 if alpha is 0.05. And this is equal to 2.576 if alpha is 0.01. So remember, the question is asking you to consider 2 different values for alpha, right? So if alpha is 0.05, you get this for the right hand side, and you get this if alpha is 0.01, right? Right, now what you need to do is you need to compare the left hand side with the right hand side. Okay, 1.731 is less than 1.96, and it's also less than 2.576. So the conclusion is the following. In either case, in either case there is no evidence to reject the null hypothesis. So that's the conclusion, that there is no evidence to reject the null hypothesis, right? So that's how you would do part 1. Part 2 is similar. Part 2 of question 1 is similar. So can you go to question 2 please now? Are you guys okay with this? Anything? Yeah, okay. Can you now do question 2 please? Question 2. Let me show you. This is the number question 2. So we're done with question 1. So it has 3 parts. Okay. So for question 2, once again you need to use the, let me show you. You need to use this test here, right? You need to use one of these tests for question number 2, part 1. Right? This is testing for population mean when the variance is known. Right? So you need to use one of these, right? Alright guys, let me make a start on question number 2. I'm sure you have done it. Some of you have done it. So let's do the first part. This is question 2, part 1. So let's write down what's given to us. We are told that n is 10, sigma squared is 3, x bar is 0.7, and we want to test mu equal to 0 versus the alternative that mu is greater than 0. Right? And if you look at the test that I just showed you, right, the rejection rule is you reject h0 in this case if x bar minus mu 0, which is 0 in this case, divided by sigma by root of n is greater than z1 minus alpha. This is the rule for rejecting, right? So let's look at the left hand side, which is x bar is 0.7, take away 0, divided by sigma, which is square root of 3, n is 10. Now if you work this out, this will be 1.275, right? And the right hand side is, we are using alpha is 5%, so is that 1 minus 0.05, which is 1.645. So once again the left hand side is not greater than the right hand side. So the conclusion is that it's the same, right? So you say there is no evidence to reject H0. Alright? Is that okay with you guys? Question 2, part 1. Yeah? Alright, question 2, part 2. Part 2 is asking you calculate the probability of type 2 error if the true value of mu is 1 or 1.5, right? So let's see how we can do this. So this is question 2, part 2. So we want to find the probability of type 2 error. I talked about type 2 error last week, right? What's that? It's the probability of accepting the null hypothesis when H1 is true. Okay? Alright? You may recall this. I think I talked about it in the review session last Friday. Okay? Now the probability of this is the rule for rejecting the null hypothesis. So the rule for accepting the null hypothesis will be the opposite of this rule. Right? So in other words, it will be x bar divided by given H1 is true. Let's take mu to be 1, right? We can do it similarly when mu is 1.5, right? So this is the rule, right? Alright, now I'm gonna do something. I will explain why I'm doing this in a minute. Right? Let me explain in a minute why I'm doing this. You see what I've done? I have subtracted a 1 and added a 1, right? And now I'm going to take this third term to the right hand side of the inequality, right? So this will become the probability that x bar minus 1 Okay, now let me ask you, what do you know about this? Do you know something about this?
Normally distributed.
Yeah. The fact is, if you don't, some of you maybe don't remember, let me write it down. If you have a random sample, IID, from a normal distribution, right, then the following fact is true. This is one of the results I talked about. If you look back on the website under the normal distribution, you should go to the website for the course and look for the normal distribution. You will see this is the result I mentioned, right? Okay. So I'm going to use this. So condition on this has a standard normal distribution, right? So this is the probability that n01 is less than or equal to 1.645 root of 10 divided by root of 3. Now, you see here that I removed the conditioning. This condition is no longer here because I have used the conditioning to argue that this has the standard normal distribution. So we don't need the conditioning anymore, right? Okay. Okay. So this will become phi. Phi is the notation for the CDF of standard normal. 1.645. All right, and if you work this out, you will get this to be 0.43. Right. All right, so that's the answer with mu equal to 1. You can do the same thing with mu equal to 1.5. So it's similar. I'm not going to do it, but the process is similar, right? Okay. All right, now let's go to part 3. So this is part 2. Are you okay with this, guys? Yeah, okay. Now let's go to part 3 of question 2, which is asking you for this. Assuming the mean is the same, how large the sample size need to be in order for H0 to be rejected in favor of H1? So basically it's asking you is this. Now what it's asking you is, remember in this is the rule for rejecting the null hypothesis in part 1, right? And the question is how long n should be so that this rule is satisfied, right? Okay. So to do this, we know the rule is that x bar minus 0 divided by sigma by root of n is greater than z1 minus alpha, which is the same as saying we know x bar is 0.7, sigma is root of 3, n we don't know, and this guy we know is 1.645, right? So we just need to work out what n is, right? Okay, we just need to work out the value for n. So this you can write as 0.7 times root of n divided by root of 3 greater than 1.645, right? So this is the same as saying that root of n is greater than root of 3 divided by 0.7 times 1.645, right? And you should square both sides. This is the same as saying that n is greater than root of 3 divided by 0.7, 1.645, the whole thing squared, right? Now if you work this out using a calculator, this will be equal to 16.5675, right? And therefore, because n cannot take a decimal number, n has to be greater than or equal to 17, right? Is that clear, guys? So the smallest sample size for the rejection rule to hold is 17, right? Okay. Right. Any questions, guys, so far? No? Yes? No? All right. Can you now do question 7, please? Because the other questions are similar. So can you now go to question 7, which is the last question on the sheet? So we've done question 1, we've done question 2. Can you do question 7? This one. This question is on proportions, so let me show you the rules now. Let me show you where they are. Okay, so if you go to the website, you will see the rule to use is this one here. So the rule to use is one of these 3 rules, right, to do question number 7. So try to think about it and see if you can do it. I'm sure you can do it. I'm sure you can do it. Just try to think about it, which one to use. Okay? This one here is the normal distribution with 0 mean. It says it's 0 mean and variance in the square. So this is the PDF of the normal with 0 mean and variance in the square. You know the numbers of PDF, right? Don't you? Come on, you should know what the PDF of the normal distribution. Yeah. It's on the website, the PDF of the normal distribution. If you type Wikipedia, you see, you type Wikipedia, you will see the PDF of the normal distribution. Alright guys, so I hope you've done it. So let me show you. I know you have, some of you have done it. So let's start with the first part of question 7, part 1. So let me change the camera. So here we are. Right, part 1. So what we are given here is we are trying to test the proportion, right? P equal to 0.1 versus P not equal to 0.1. And we are told, alright, the rejection rule, just the one I just showed you on the screen. The rejection rule in this case is the following: x bar minus 0.1. I showed you just on the screen right now. Is x bar is the sample proportion, not to be confused with the sample mean. In the absolute value greater than z 1 minus alpha by 2. This is the rejection rule, right? So let's try to work out the left and the right hand side. So the left hand side is gonna be x bar is 47 divided by 400. So because there are 47 people out of 400 who are left-handed, right? So the sample proportion is 47 divided by 400, 0.1. Alright, this is the one. And you should compute this using a calculator. This is what you will get. Alright, this is the left hand side. And the right hand side, we are using 5%, so this is gonna be 0.975, which is 1.96. So once again, the left hand side is not greater than the right hand side. So the conclusion is that once again there is there's no evidence to reject the null hypothesis. Alright, so this should be straightforward for you guys, okay? Part 1 of question 7. Right, part 2 of question 7 is similar to what we did earlier, right? So part 2 is asking you find the probability, approximate probability that we correctly reject H0 when the true value of P is this or this. So we want to reject H0 when P, so let's say take to be 0.103, right? Similar for the other one, right? So this is the same as saying that the same as saying this. Right, this is the rejection rule that we saw earlier, right? Now, what I'm going to do is, I'm not sure whether you know this, that if you have inequality like this, right? This is the same as saying that Z is greater than A or Z is greater than minus A. I'm sure you know this, right? You must have seen this in your math courses, in one of your math courses, I guess, right? So using this fact, right? Using this fact, you can write it like So you see what I've done? I have used this inequality, right, to write this like this, right? This is all, right? Now these two events, this event and this event, are mutually exclusive, which means that, remember from probability 1, you should know that if the probability of the union of two mutually exclusive events is the sum of the probabilities. So using that, fact one more we can write this probability as so you see what I'm doing? Are you guys with me or not? If you're not, just give me a shout. Give a shout to me. Alright? Okay guys, now the next thing what I'm going to do is, because the true proportion is now 0.103 and not 0.1, what I'm going to do is I'm going to change 0.1 to 0.103, right? So I'll do that as follows, because right? Okay, you see why I'm doing this in a minute, because in the next step what I'm going to do is I'm going to take this guy here to the right hand side, right, and also I'm going to take this guy here to the right hand side, right? And if you do that, you will see this. Right, and the second term will become like this. Right, okay, and in the next step, I'm running out of time, but in the next step I'm going to use the fact, and this is something that I mentioned to you before in a class, in one of the review sessions, and also in the notes, printed notes as well as the written notes, that this guy here, condition on the true proportion being equal to this, these two guys have the standard normal distribution approximately, right? Approximately, given n is large, these two, given this one and this one, these two have approximate standard normal distribution. So this will become n01 greater than 1.96. Once again, I have removed the conditioning because I'm going to remove the conditioning because I have used the conditioning to argue that the approximate normality, right? So I no longer need the conditioning, right? Plus the probability that okay, so we are nearly there. So the final step is gonna be, we're gonna write this as one, the first term you can write it as 1 minus phi at 1.96 minus 0.003 divided by this, right? And the second term you can write it as phi at minus 1.96, 0.003 like this, right? So, and you can work this out using your calculator, and if you do it, let me see what value you get. You should put the value for x bar and the value for n, which are given in the question. You will get this to be equal to 0.058. Right, so that's the probability of rejecting H0 when the true value of P is 0.103. Right. Okay. You guys okay with this? All right, good. All right, guys. So I'll see you tomorrow. I hope you're coming tomorrow to the class. And any questions you guys have, just feel free to contact me 24/7 by email or Skype or Zoom or whatever, or come to my room upstairs, 2.2 to 3. All right. Okay. Have a good day, guys. Have a good day.